Hello everyone. Today we will see how to use ResNet50 model for transfer learning. In this video we will see how to classify images by using the pre-trained ResNet50 model. In this video we will see binary classification on cats and dogs dataset from Kaggle. We will download the dataset cats and dogs dataset from Kaggle and use this dataset to retrain some of the layers of ResNet50 model. First of all, we see the base model of ResNet on this dataset. First of all, we will see the performance of our base ResNet50 model on this new cats and dogs dataset. And then we optimize the ResNet50 model on this dataset by using transfer learning technique. So let's first of all we will see the architecture of ResNet50 model. Here is ResNet50 model. It has 5 stages and here you can see these top layers: global, average, pool, flatten and dense. This is the top layer or end layer. In base model we will not use this layer. We just use this base model to see the performance on our new cats and dog dataset. After that, when we will optimize, we will add some dense layers and we will unfreeze some of the top layers and retrain the weights of these top layers and see the performance of model. We will also tune hyperparameters like learning rate to improve the performance of this ResNet50 model on this new dataset. Here is a link of dataset from Kaggle to download. This is the cats, dogs versus cat dataset from Kaggle. We will use this dataset for transfer learning. First of all, let's go to this dataset and see on Kaggle. Now you can see that here is the dataset dogs versus cat. This is dataset and here are our three files: test, train and sample submission.csv, and dataset in zip folder: test zip and train zip. In this lecture we will not use our local environment. We will use Google Colab for this task. Let's go to Google Colab and see how to download this dataset. Let's go to Google Colab and I have already write the code for this ResNet50 optimization. Okay, in this we will use ResNet50 model for transfer learning and this is the binary classification task. First of all we will download the dataset from Kaggle. For that we will install Kaggle. Okay, first of all we connect to our runtime to GPU. Here is we will select a GPU and save and let's connect it. Let's wait. Here we have connected to T4 GPU. Okay, let's say first of all we install Kaggle. Okay, for that we will run this cell and here Kaggle is installing. Then for this you have to account on Kaggle. First of all sign up to Kaggle so that you can access the dataset and open the link. Go to this link. You can find this link from comment and you will get this page. After login you will click here and click settings. From settings here you will find create new token. When you create new token and after creating new token you will download the Kaggle.json file. The JSON file will be downloaded on your download folder. Here is my download folder and here is the .json file, Kaggle JSON file. After this what you will do, you will run this cell and upload this JSON file from download folder. I have uploaded this. You will execute here. You can see it will execute successfully. Okay, after that you will run these 3 lines of code. This line of code will create a directory in which you will place your JSON file. The Kaggle API requires this JSON file and this JSON file have API credentials. Okay, which is placed in this directory for authentication. Okay, what the purpose of this line of code? This line of code move the Kaggle JSON file to in the current working directory. Okay. So this command, after running this command, only the owner has the access to read or write this Kaggle JSON file. Okay. And let's run this line of code. Okay. After that we will run this line of code to download the dataset from Kaggle. Where you find this line of code, you will see here in Kaggle. If you go to, you will find here, you will find the this line of code from here. Here is the exact name of the file. When you put this in here, it will download the this specific data set. Okay. After that, when you download this, you can see here you can see the over data set is downloaded, but this is in the form of zip folder. Let's unzip this folder. For this we will run this line of code, and here you see our data is unzipped. Okay. Here you can see our trained and test. Again our trained data is also in zip file and test data is also in zip file. Again we will unzip these files. Okay. Again here is the code to unzip these files. You can see here is the training set. Here is your trained data set. Similarly folder again test, it is test data set. Okay. Let's separate the data set, because our cat and dog data set in test and train folder are mixed. We will, in our train data set, the dog and cat data set are combined. We will separate cats and dog directory. Okay. Here we will you can see, and we will first give path of this train data set path. Here is the path. You copy path here and paste the path here. Okay. I have already copied, and here you can see we have create a separate directory for cat and dog. Okay. For that, the cat images are go to their respective directory cat, and dog images go to their respective directory dog directory. Okay. After running this line of code, okay, now our data set is separated. Cats are separated from dog. Okay. Now let's install TensorFlow. Here we have the code for split the data set into train and validation set. We have used 20% of the data from train set for validation, and image size is 224 into 224, and batch size, we have set batch size 64. It's mean during training one batch consists of 64 images. Okay. Let's run this line of code, and here you can it will split the data set into. After, you can see that found 25,000 files belonging to two classes. Using 2,000 files for training, found 25,000 files belonging to two classes, use 500 files for validation. Our dataset, training dataset, has total 25,000 images, out of which 5,000 images we have used 5,000 images for validation. Okay. Now let's scale over these images, because the image is not scaled. We will scale the images first. Okay. Now scale down the images. After scaling, now first of all, I have already told you we will use our base model. Okay. As you can see, we have used ResNet50 model, and here we have initialized the base model, and we have just connected global average pooling layer, and after that we have connected over dense layer with one neuron. Okay. And activation function is sigmoid, because we are going for binary classification. For that we use sigmoid activation function. As you can see, we have only here we have set include top is equal to false. Include top, when you set this false, it's mean we are not using flatten and dense layer of the ResNet50 model. We just use base model and see the results performance of this base model on which is pre-trained on ImageNet dataset, and see the results. Here you will just connect one neuron to the output, and here you will set training it equal to false. This means you are not training the model. And we have used SGD, stochastic gradient descent, and we have set learning rate 0.1 and momentum 0.9. Okay, let's run this base model. Okay, our model is ready. Now we will see this model is already trained on ImageNet dataset. Base model we will not train. We will just give over this new dataset from cat and dogs and see the performance of this model. Okay. We will see the performance of this model on cat and dogs. And here we run this line of code and we will check how this base model is performing on this new dataset. We are not training this model more. We will use the pre-trained weights for this and check the results of the training and validation dataset on this base model. Let's wait. And now training dataset has completed, as you can see here, accuracy and loss. Okay. Here you can see the training accuracy. It has only 0.38% and validation accuracy is also 0.38%. This is a very low accuracy. Okay. And because one more thing, this is the balanced data set. So in this case, our cats and dogs are balanced. The number of images of both classes are equal in training and validation data set as well. So accuracy is the good measure for this. Like but we will also see the confusion matrix to see the precision and recall. Let's see the confusion matrix and precision and recall score. Let's check the precision and recall score. Okay. As you can see that precision is 0.38 and recall is 0.31. This is very low value. And now let's calculate the confusion matrix. Here you can see confusion matrix and the results are very bad. False negative 1293 and false positive 1770. Okay, here is true positive, true negative. So you can see that confusion matrix, the results are very bad. In this, our positive class is dog, okay, and negative class is cat in this case. So you can see that this model wrongly classified 1293 pictures of dog. Similarly, this model wrongly classified the 1770 pictures of cat. Now let's optimize this model and using transfer learning. Okay. Here you can see again we have set include top is equal to false, and we have connected the global average pooling layer, and we have connected one dense layer, and after that we have connected our final prediction and with sigmoid activation function. And here we first freeze the layers and then we will unfreeze the top 5 layers. We have top 5 layers of the ResNet50 base model, and now train the model. Okay. First of all, run this. We have also set learning rate 0.001. Let's run this and see how it is performing. As you can see, our accuracy is improving. In first epoch, accuracy is 91%. That's very good. Let's see the validation accuracy. Yes, you can see validation accuracy is 0.98. As you can see, accuracy is continuously increasing and loss is continuously decreasing. And validation accuracy is also increasing. And validation loss is decreasing also. As you can see, accuracy is 0.9960 and loss is 0.0140, and validation accuracy is 0.98. This is actually the very good training, because the gap between training accuracy and validation accuracy is less, 0.99 and 0.98. Let's see the precision and recall score. Here you can see that the precision is 0.99 and recall is 0.98. Let's draw the confusion matrix and see the results. Here you can see false negative drops to 20 only and false positive 46. In earlier case you can see that 1293 1770. This is the result of base model, and after optimization you can see that here is the model is trained very good. Minimize more. Let's minimize false positive more. We can still optimize this. Let's unfreeze more layers. In earlier case we have just unfreeze 5 layers, but now we unfreeze more layers. We unfreeze 25 layers. Okay, here we have unfreeze 25 layers, and learning rate is same. Just we unfreeze 25 layers, and let's run it for 20 epochs. Let's see what happened. Error. Model OP3 is not defined. Okay, I have not run this. Let's run this, and after that now run this. Here it is. It will take too much time to train. Let's wait and see the results. Okay, here you can see on epoch 15 the accuracy is 0.999. Here you can see the loss is continuously decreasing. It goes to 0.0012. Here you can see it has now model is fully optimized. Let's see the precision and recall. Here you can see the precision is 0.99 and recall is also 0.99. This time both are very good. Let's see the confusion matrix for this, and here it is. You can see that now false positive drops down to 28 and false negative 29. This is little bit high, but false positive also down. And now compare all these. Let's see. Here you can see the comparison of all three models. Here is the base model, here is optimized model with 5 layer unfreezen, and here is optimized model with 25 layers unfreezen. You can see that false negative 1293, false positive 1770, false negative 20, false positive 46, and here is false negative 29 and false positive 28. And here is the accuracy, precision, recall. You can see that accuracy is 0.39 and here accuracy is 0.99, and with the 25 accuracy is 0.99. Here base model accuracy recall is 0.31, and here recall is 0.98 and recall is 0.99. Okay, as you can see here it is over optimized model. Okay, so this is it for today. See you in the next video. Thank you very much.